another brainfix video. In this one, we're going to look at how to use permutation and what permutation is. Okay, to start with, we must first begin by understanding how to use factorials. So in our previous videos, we've learned what a factorial of a number is, where we said 5 factorial is 5 times 4 times 3 times 2 times 1. In short, it's just the product of all positive integers from 1 to that particular given number. So all positive integers. Yeah. Now, how do we use factorial in real life situations? So one way of using factorial is in arranging of items. So factorials, they are used in arrangement of items. So you might have a question like they might say you're given 3 items denoted by 3 letters. Then you are told to state the possible number of arranging these 3 letters or these 3 items. So normally by analysis, we can say this can be arranged as A, B, C. The other way of arranging these letters is A, C, B. The other one is by starting with B. Then you say B, A, C, or B, C, A. Or we can begin with C. It's also a possible arrangement where we say C, A, B, or C, B, A. So when you count these possible ways of arranging ABC, we can see that we have 6. We have the first one, the second, third, fourth, fifth, and the 6th. So there are 6 ways of arranging 3 items. But we can find the result. We can get 6 by using factorial, where we can just say, how many items do we have? We have 3. And the every arrangement, we need to have 3 items. So since this question is straightforward, we can just count the number of items given. And the number of items given is 3 factorial. And when you evaluate 3 factorial, you will see that 3 factorial times 2 factorial, or 3 factorial times 2 times 1, you're going to end up with 6. So that's how we can apply factorials to find the number of possible arrangements of given items. By the way, this is the other way of defining what a factorial is. You can just define it as, you can define n factorial as number of ways of arranging, n objects. So in this case, we imagine that the number of objects given, it's n. So just the number of ways of arranging n objects on a line, by the way, I need to specify. We are arranging these things on a line. The other way of arranging things, it's in a circle. Now we are going to tackle that one in a different video. Meantime, let's focus on arranging them in a row or in a line. So that's what we mean when you say factorial. Okay, let's start a more practical example and see how to apply factorials. Okay, so you might be given a question like this one. How many arrangements are there of the letter FISH, which can be read as fish, and how many arrangements are there for the letters CAT, which can be read as cat, and how many arrangements of letters are there for the word computer? Okay, let's begin with the first one, cat. For cat, we can first arrange it this way. The second arrangement can be F, where we interchange the two. The other one can be F, where we say H, I, S. We can have F, we can have F, H, S, I, so on and so forth. So you end up with a list of 24 as your list. But when you see just 4 factorial, we can see how much work we need in order for us to list all the possible arrangements. So there is an easy way of finding the possible arrangements for a given number of letters. So for this one, just say 4 factorial, as Zera said. So what we can do, rather than us stating a list, then counting the number of possible arrangements, we can just count the number of letters given. So the number of letters is 4 for this one. So we can say A has a total number of 4 letters. And we can find the possible number of arrangements to be 4 factorial, which is equal to 4 times 3 times 2 times 1. And this is equal to 24. So that must be your answer. Okay. For cat, it has a total number of 3 letters. And that will be 3 factorial, which is equal to 3 times 2 times 1. And that will be equal to 6. As total number of arrangements that can be made from the letters C, A, T. Okay, now let's jump to C. So C has how many letters? 1, 2, 3, 4, 5, 6, 7, 8. It has 8. It has 8 letters. So it's 8 factorial. And 8 factorial, it's 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. And when you punch this into your calculator, you're going to get the value. It will be 8 times 7, that's a 56, times this part. Okay, so this entire part, okay, 6 times 5 factorial, we know it's a 120. And when you multiply everything, you must get 40320 as your answer. So that's how you go about a question like this one. Okay, now, how can you use permutation to find the solutions of this particular problem? Okay, so here's a definition for permutation. Let's get rid of everything. So when you say permutation, it's also ways of arranging items. But the good part about the permutation formula is that it's more of a condensed way of finding ways of arranging items. Yeah, in other words, it's a better way of finding the number of ways of arranging items. You'll see the reason why it's a better way. So the formula looks like this: n factorial divided by n minus r factorial. And if you are given a question like this one, we can arrive at the same answer by just saying n is a number of items present or given. So for question A, our n is 4. While r it's the number of items that must be present per arrangement. So in each arrangement, how many number of items must be present? That's what is denoted as r. So in this case, we want to arrange 4 items per arrangement. So we are going to end up with 4 permutation 4, which is equal to 4 factorial divided by 4 minus 4 factorial. And this will be equal to 4 factorial divided by 0 factorial. We know that 0 factorial is equal to 1, so this is same as 4 factorial, which is the same with what we got in our first method. So that's how we apply permutation to find the number of possible arrangements. Now, why is it that this formula is better than the approach of using factorial? Okay, so the question is, how many 3-letter arrangements that can be made out of the letters acid? So we need first to know the number of letters present in that particular word. So we have 1, 2, 3, 4, 5. So we can say n is equals to 5. We have a total number of 5 letters. Then we are told that we need to make 3 letters per arrangement. So looking at our formula for permutation, which looks like this, as earlier said, we can say R, which represents the number of letters per arrangement, is equals to 3. So now let's substitute them in our formula. We are going to end up with 5 permutation R is equals to 5 factorial divided by 5 minus 3 factorial. And this will be equal to 5 factorial divided by 2 factorial. Now let's expand it. We know that 5 factorial can be written as 5 times 4 times 3 times 2 times 1. And the denominator can be expanded as 2 times 1. This part and that part can cancel. And we end up with 5 times 4 times 3 divided by 1, but no need of adding that. We know that 5 times 4, that's a 20, and a 20 times 3, that's a 60. So that would be our answer, 60. So I guess you can now appreciate the importance of this formula. So that's how we apply this formula in calculating the number of arrangements. Okay, let's now deal with something a little bit different. Okay, now we have another question, which reads, in how many ways can 2 red, 3 yellow, and 4 green balls be arranged in a row if balls of the same color are identical? So in this question, the keywords are balls of the same color are identical. And the other keyword, it's law. So we are dealing with something that is arranged in a straight line. So now I want us to focus on this last part, which is identical. So if you encounter a question of this kind and you are told that you have a particular number of items that are grouped. So when you look at it, you can see that it's grouped. We have a group of 2 red balls, then we have another group of 3 yellow balls, then we have a group of 4 green ones. So this question has groups and they are identical. So items in each group, they are identical. So we need to take that into consideration. So if a question of this kind came in an exam, you need to use a formula known as the permutation of mount sets. So we are saying we use the formula called permutation of mount sets. So the formula looks like this: n permutation R. Actually, no, we don't say n permutation R. The formula will look like number of arrangements. Yeah, number of arrangements is equals to n factorial divided by n1 factorial, this is group 1 elements, followed by group 2 elements, followed by group 3 elements, so on and so forth. So if you have maybe 5 groups, you do the same. So this is the formula you need to familiarize yourself with. So let's see how we can handle this question. So we are told that we have a total number of how many elements present or items present. We have 2 there, so we are saying n is equals to, we have 2, we have 3, so you're going to say plus 3, then we have 4. So we have a total number of 2 plus 3, that's a 5, and 5 plus 4, that's a 9. So you have a total number of 9. Then in group 1, let's call it a set. So in set 1, which is a set of red balls, we have 2 items. Then in group 2, which is a set of yellow balls, we have 3. Then in group 3, we have 4. Now it's just a matter of now replacing this into our formula. Let's do it. So, okay, by this time I guess you've mastered the formula. So we are saying to find the total number of arrangements, it's n factorial divided by n1 plus, or not plus but times, n2 factorial, by the way, factorial, times n3 factorial, which will be equal to 9 factorial divided by 2 factorial divided by, or multiplied by 3 factorial multiplied by 4 factorial. Now from there we can see that when we punch 9 factorial in your calculator, you're going to get a, let's see, 9 factorial. You're going to get a value of 362,880 divided by 2 factorial, it's a 2, times 3 factorial, it's a 6, times 4 factorial, that's a 24. Then from there, I'm going to get the value. We are saying number of arrangements will be 362,880 divided by 24 times 6 times 2 will give us the value 288 is equals to, when you divide the 2, you're going to get 1260 as your answer. So that's how we go about a question like this one. Very easy and straightforward. Don't forget, for permutation, we have 2 formulas. We have this formula, that is if you're not given items that are grouped. But if the items are grouped, then you use this formula. N factorial divided by n1 factorial multiplied by n2 factorial multiplied by n3 factorial. So that's how we go about a question of this kind. Okay, let's handle another question that is similar to this one and see how best we can handle it using our new introduced formula. Okay, so here's the question. Given the word algebra, how many ways can the letters be arranged in a row? That's part A. Then part B says, in how many of these arrangements are the 2 A's, take note, are the 2 A's together? So take note of that. Then the last part reads, in how many of these arrangements are the two A's not together? Quite interesting. Okay, let's see how we can do it. Let's begin with part A. So we are saying answer. So the first part is A. We are told how many ways can the letters be arranged in a row. So we need first to know the number of letters present in algebra. So we have 1, 2, 3, 4, 5, 6, 7. So n is equals to 7. Now we need to look at the word. Do we have repeating letters? Yes, we have A there and another A there. So we need to take that into consideration. So because of this, we are going to use the formula for permutation of multi-set, which is n factorial divided by n1 factorial times n2 factorial times n3 factorial. Let me repeat what I said. I said, since in this word we have two repeating letters, that will make us not to use the usual formula for permutation, but rather we are going to use the multi-set formula for permutation, because we have one set of what? Of items in it. So if you're given any question or any word that has repeating letters, then it's advisable to go by this formula. So let's look at the set. How many sets do we have? We only got one, so it will be n1 is equals to how many elements are present in that particular group. It's only 2. We have 2 A's, one here and the other one there. That's it. Okay, we can now do it. We can just say 7 factorial divided by, we have one set, so it will be 2 factorial. And this will give us 7 factorial divided by 2 factorial. 7 factorial, that's 7 times 6 times 5 times 4 times 3 times 2 times 1 divided by 2 times 1. And let's see the answer when I plug this in my calculator. So we are saying 7 factorial divided by 2 factorial. And my value is 2520. So that's my answer. So that's how easy it is to handle the first part. Now we need this answer. Let's put it there. So we are saying the answer was 2520. Okay, let's clear everything and jump to the next part. So the next part says, in how many of these arrangements are the two A's together? Two A's together. So since the question says two A's together, we are going to consider the group or the set that is consisting of A's as one element. Let me repeat again. Since the question says the two A's has to be considered as together, we are going to combine them and form and count it as one element or one item. So instead of having 7, we are going to have a total of 6. Yeah, let's count it. We are going to have 1, 2, 3, 4, 5, 6. We won't count this one because we've already counted A. So we are going to have a total of 6. So we are saying n will be equal to 6. Now, do we have any other group of elements in this word? The answer is no. So because of that, we are going to use the usual permutation formula, which is permutation, that one is equals to n factorial divided by n minus r factorial. So since we have no groups, we only have n is equals to 6, it will be easy. So it will be 6 permutation. Now, per every arrangement, we need to have 6. So that will be n factorial divided by n minus 6 factorial. Now, n is 6, by the way. So let's put a 6 there, which will be equal to, can get rid of these things this side, and we're going to get a 6 factorial divided by a 0 factorial, which is same as a 6 factorial. And when you plug this into your calculator, you're going to get a 720. Yeah, 720. Since, yeah, 720, that will be your value. Okay, so that will be your answer on question, on part B. Okay, let's now dive into the last part. So the last part reads, in how many of these arrangements are the two A's not together? Not together. I want you to pause the video and think, how can we go about this question? You're told to find the number of arrangements if the two A's are not together. Okay, let's do it. So if you're told to say the two A's are not together, and we know that when they were together, our value was, we said our answer on B was 720. So this was our value if the two A's were together. Now, if you want to find the number of arrangements, if the two A's were not together, you can just say total number of arrangements. Oh, we are saying arrangements is equals to, it's equal to A's not together. So when you make arrangements of A's not together, what am I writing? We are saying together. And you add it plus A's together. What you're going to get when you add the two, you're going to get the total number of arrangements. And this is logical because if A's are not together, then they must be together. And if the A's are together, the other option is where A's are not together. So when you add the two, you must have the total number of arrangements if you're not considering these two conditions at all. So they're like opposite to each other. This one is the opposite of that. And when you add them together, you add these two together, you're going to end up with that. Okay, now it's just a matter of substituting your values into this particular equation. Total number of arrangements, it's what we got in A, which is 250 is equals to. Then not together is what we want. So we're going to say is not together. Then plus A's together, it's 220. And we're going to end up with A's together is equals to 2520 minus 720. And when you punch this into your calculator, you're going to get a 1800 as the total number of arrangements if A's are not together. So that's how you handle a question like this one. Very easy if you are thinking. Yeah. Okay, thanks guys for watching. I'll meet you in my next video.